When you strip away the hype, blockchain in enterprises and governments comes down to reusable patterns for trust. In this module, we'll turn vague ideas into concrete blueprints you can apply. Shared registries, notarization, and multi-party workflows that can actually survive compliance reviews. Modern collaboration across enterprises and agencies is fundamentally a trust problem. Each organization maintains its own version of the truth, and traditional APIs only shuttle data between those islands. They synchronize messages, not trust. That leaves no single agreed master record. The result is constant reconciliation, endless who has the latest copy debates, and slow manual checks. Fragmented audit trails then make detecting errors, abuse, or fraud significantly harder. When you design blockchain-based trust infrastructure, think in three reusable patterns. First, shared registries. This is your single, authoritative view of who and what exists: organizations, licenses, identifiers, keys, or reference datasets. The benefit is controlled, write access with a globally visible history. Second, workflow orchestration. Here, smart contracts coordinate multi-step, multi-party processes, approvals, handoffs, and status changes, with rules enforced by the network rather than a single system. Third, notarization and evidence. You anchor hashes, decisions, and timestamps, so later you can prove this existed in this form at that time in a tamper-evident way. The shared registry pattern treats the blockchain as the master record that multiple organizations rely on. Instead of everyone maintaining slightly different copies, they co-own one authoritative view of core data. Updates are written once and immediately reflected for all parties. Access is permissioned, so participation is controlled, but no single actor owns the truth. The outcome is consistent data, predictable governance, and an auditable history that everyone can verify. When we talk about governance and access control in blockchain networks, we're really talking about structure, not decentralization for its own sake. First, identity. Every permission network must define who is allowed to issue, approve, or revoke actions and credentials. Second, the data model. Typically, only essential proofs and state go on-chain, while bulky or sensitive data remains off-chain. Finally, consortium rules define onboarding and offboarding participants, and how disputes are resolved. Let's make shared registry concrete. In government, think of professional licenses, vehicle titles, or land records. Today, each agency or region often runs its own database, and reconciling differences is painful and slow. A permissioned ledger lets them maintain one authoritative history, with append-only updates and cryptographic proofs. Enterprises face the same issue with KYC data, product catalogs, and supply chain master data. Shared registries give them instant verification and virtually no reconciliation work. Notarization and evidence use the blockchain as a digital notary. You keep the real documents in your existing systems and write only a cryptographic hash to the ledger. That hash is your anchor. If anyone alters the off-chain file, its hash changes and no longer matches what's on-chain. That mismatch is your tamper evidence. Because blocks are timestamped and ordered, you also gain proof that a specific version of that document existed no later than that block time. This pattern is powerful because it delivers strong integrity and time evidence with minimal data, cost, and regulatory impact on the chain itself. Privacy architecture is about getting the benefits of a shared ledger without leaking sensitive data. The guiding principle is simple. Personally identifiable information lives off-chain, proofs live on-chain. Treat the blockchain as a notarization layer, not a document store. A secure database or document system holds the real records. The chain stores hashes and metadata. When policy demands deletion, you erase off-chain data, and the remaining hash alone reveals nothing useful. Evidence trails are where blockchain's immutability becomes very tangible. In commercial settings, you can anchor contract hashes or IP assets, so you can later prove exactly what existed and when, without revealing the full document on-chain. In healthcare and science, clinical trial milestones and data transformations can be logged, making it extremely hard to massage results after the fact. For public agencies, notarizing notices or procurement events creates a defensible end-to-end audit trail. Workflow orchestration moves you from passing messages around to sharing a single, trusted view of the process. Instead of each organization maintaining its own version of the workflow, a smart contract holds the canonical state. Every step updates that shared state under agreed rules. With atomic updates, either the whole transition happens or none of it does, and all participants see the new state at the same time. As you move from proofs of concept to real systems, complexity becomes the main design challenge. You need to model real-world processes as explicit states and transitions that smart contracts can actually enforce. Whatever happens on-chain must then be reliably connected back into legacy ERPs and case management systems. And because things will go wrong, you must design controlled escape hatches where humans can pause, override, or correct the automated flow. Workflow orchestration is where blockchain starts to feel very concrete. Think of customs clearance or trade finance. Today, each party runs its own workflow, reconciles later, and pays a coordination tax in delays and disputes. With a shared ledger, the workflow becomes a single, jointly managed state machine. The same pattern works for interagency case management, grant approvals, or procurement from RFP to payment. Everyone advances the same record, with rules enforced by smart contracts, not email threads. Think of your trust infrastructure as a three-part system that has to play in tune. First, a shared registry. This is the authoritative ledger of identifiers, statuses, or licenses. Everyone reads and writes to the same source of truth under governed rules. Second, evidence. Cryptographic anchors for the documents and events that justify those registry entries. That's how you prove why a status exists. Third, workflow. The multi-party process logic that moves a case from request to approval to revocation. Strong designs keep these three loosely coupled, so each can evolve, scale, and be governed independently. Use this as a quick mental routing table when someone says, "We should use blockchain." If the main pain is keeping multiple copies of the same reference data in sync, you're in shared registry territory. Start by modeling a single governed dataset with clear writers and readers. If the real need is to prove something existed or happened at a point in time, you're looking at notarization or anchoring. If the core problem is coordinating multi-party steps, approvals, or state changes, that's a workflow pattern, likely with smart contracts. As you move from technology to trust architecture, keep three habits. First, always start from a concrete business or policy problem. Blockchain is a means, not the goal. Second, map that problem to a clear pattern you understand end to end. And third, treat governance, security, and compliance as first-class design elements, just as important and deliberate as your code and infrastructure choices.